In this question, we're looking at an amphitheater. The seats are arranged in semicircular rows facing a domed stage. So what does that look like? So a domed stage, say it's a round stage, semicircular, that means the seatings go like this. And they get successively larger and larger. Okay, so they come down here. So you get the idea. Okay, this is the center, and the rows go 1, 2, 3, 4, and they keep going backwards. So the first row contains 23 seats, and each successive row contains 4 more seats than the previous one. So the first row would be 23, the second one would be 23 plus 4, which is 27, 31, 35, and I think you get the picture that this is an arithmetic sequence. And our general term in that case will be the first term plus n minus 1 times the common difference. For the number of seats in the 45th row, well, just take my formula, which I will cut here, paste it here, and I'm going to remove the n, replace it with 45 because it's the 45th row I'm looking at. And when all is said and done and I crunch these numbers, I get 199 seats in just the 45th row. So this question tells us in part C that we know there's 6,050 seats. How many rows are in the amphitheater? So in this case, I know what the sum is. What I don't know is how many terms I'm adding together. What I'm going to recall is my sum formula. Okay, one of them for an arithmetic sequence. And that is the one that includes the first term and the common difference, which is 4. You remember that we have 2 formulas for sum. I'm using, in this case, the first one, or the second one, sorry. And what am I going to do here? I know that my sum is 60/50. I know my A value is 23, so that's 2 times 23. And I know my D value is 4. So what can I do here? Let me start simplifying my expressions. Let's see what we get. So first off, I notice that this 2 divides this term and this will bring it down to 2. So I get rid of my denominator and I'm left with 60/50 equals n times 23 plus 2n minus 2. So I brought this 2 inside the brackets. Next I collect like terms, so I get 60/50 equals n bracket 21 plus 2n. And then I bring the n inside the brackets. 60/50 equals 21n plus 2n squared. Let me bring everything over to my right hand side and flip the equation so that I have everything on the left. I have 2n squared plus 21n minus 60/50 equals 0. Now with this, I can either try solving this by using factoring of complex trinomials, or I can choose to use a quadratic formula, which if I'm pressed for time, I want to make sure that I get the right answer as soon as possible, and the formula is probably the best way right now. So let me pull that up. So it's negative b, so negative 21 plus or minus the square root of 21 squared minus 4 times 2 times negative 60/50, close bracket, all over 2 times 2. Now I've already crunched these numbers, and it turns out that I get n equals 50 or n equals negative 60.5. Since we can't have a negative number of terms, I have 50 terms in total, and therefore we have 50 rows.